All right, let's do some application of these trig problems, but we're going to start off with sort of the bread and butter. So, we've got some angle here, 40 degrees, and we know that the adjacent side is 30, that's the right angle, and the hypotenuse is x, so we can set up that cosine of 40, and remember that cosine is a function, it takes in an angle, and it returns the relationship between the adjacent side and the hypotenuse, and so that relationship should be 30 over x. And if I wanted to solve for x, I want to get that in terms of x, so I multiply by x, and then I have x cos 40 equals 30. And so the last step would be to say, okay, I want to isolate x completely, so I'm just going to divide both sides by cosine of 40. So we get that x equals 30 cos 40. Now, for the time being, let's actually get an answer to this. So I have been using Desmos to do most of my solutions. So in Desmos, you can just type in, you can just type in 30 divided by cos 40. And when you do that, you can just type in, 30 cos 40, that's what we got here, and it gives you the answer. So that tells you that our hypotenuse, this x value, equals 39.16. All right, let's do another example. So now I want to find x again. That's very similar to the last one. Let's change this just a little bit. Let's move x over here. So now, since I know the opposite side, so the opposite side of the angle and the adjacent side, and again, this is a right angle, we know that if it's opposite and adjacent, we're talking about the relationship of tangent. So remember, tangent is a function that returns a ratio of the opposite side over the adjacent side. So if I want to find x, I just multiply by 10. And that's a much easier one to solve. We get x equals 10 times tan of 50. So as we can see, x equals 11.92, and I just rounded it up. Okay, two more. This problem's a little bit harder. Let's suppose we've got this set up where if you're located at this edge of the right triangle, you have to look up at a 20-degree angle to see the top of this height. And if you move 30 units, now you have to look up at an angle of 50 degrees. So we want to find both x and h. And what's interesting is we don't know any length, except we know that we move from our starting vertex, we move 30 feet to get to our new vertex. So we could then sort of call this, if that distance is 30, the inside distance must be x minus 30. Okay, well now we've got some triangles to work with. So if we look at the kind of outer blue triangle, what we have is, well, we've got our opposite side and our adjacent side. So we have tangent of 20 equals h over x. And then if we look at kind of that inside triangle, we have tangent of 50 equals h over x minus 30. All right, well, there's a number of ways of solving this. I think maybe the easiest one for now would be to get these so that there are no fractions. So I'm going to multiply the top equation by x, and the bottom equation by x minus 30, and x minus 30. So then we've got an equation where my x's cancel off, the x minus 30's cancel off. So I have x tan 20 equals h from the top equation, and I have h equals x minus 30 tan 50 from the bottom equation. Well, if I simplify this right-hand equation, so remember this is coming from here, if I expand it, I get x tan 50 minus 30 tan 50. And that's h. But I also know that h is x tan 20, so I can use substitution. So we can say x tan 20 equals x tan 50 minus 30 tan 50. And here's the, we need to use the technique that we're trying to solve for x. So let's move everything with an x over to one side. So we have x tan 20 minus x tan 50 equals negative 30 tan 50. Well, since I have an x on both sides, what I can do is I can factor out an x. So now I can write that as x times tangent of 20 minus tangent of 50 equals negative 30 tan 50. So the last step here would be just to divide by tangent 20 minus tangent 50. Now remember, that's just a number. Even though it looks a little bit weird, tan 20 minus tan 50 is a number. But don't put it into your calculator until the very end, because that will avoid you having a bunch of rounding off errors. And also, resist the urge to cancel this tan 50 and this tan 50, because in the denominator, we're not multiplying those together. They're being added and subtracted, so you can't cross off. Okay, cool. So now what we have is x equals negative 30 tan 50 over tan 20 minus tan 50. And we'll use Desmos to solve that. So here we get our solution for x. X equals 43.19. Okay. One more. Let's suppose that you are standing in front of a tree, and you're 5 feet tall, or it's 5 feet, let's say it's 5 feet to your eyesight, and you're standing horizontal distance x from a tree, and let's say that x equals 100 feet. So it's a horizontal distance to this vertical tree, so that's a right angle. And you have to look up to the top of the tree at an angle of 24 degrees. And you want to know, what is the height of the tree? Okay, well, I think the easiest thing to do would be to say, okay, let's first find this height, because we need to look at this triangle. So let's look at this height, and we know that this distance is 100, so we could say that h over 100 must equal tan of 24. And therefore, h must equal 100 tan 24. But if I'm looking for the total height, I need to add in the 5 feet to my eyesight. So the total height is going to be 100 tangent 24 plus 5. And again, this is something that we can use Desmos to calculate. So we found that x equals 49.52.